let's take a few minutes and cover the tools necessary for proper inspection of our finished parts. Keep in mind the type of tools that are necessary directly depend upon the quality and preciseness of the work that you're doing. If you're working for automotive race car guys, if you're doing work for Farmer Brown down the road, we're not going to be dealing in 10,000ths of an inch in most cases. Usually plus or minus 2, 3, 4, 5,000ths is more than adequate for these industrial type applications. If you're building parts for aerospace or the military, by all means, they're going to require you have some pretty heavy duty inspection equipment at your disposal. A pair of dial calipers, like I show in my hand, is going to cover, for all practical purposes, 99% of the work in general application, industrial applications, agricultural applications that you may encounter. It's also a good idea to have a good set of micrometers, a 0 to 1 inch, a 1 to 2. This allows us to measure in 10,000ths of an inch on diameters, thicknesses of parts that may be critical depending upon their application. Micrometers made by the folks at Starrett, Mitutoyo, or Brown & Sharp would be my recommendation to put in your toolbox. Having a good depth mic, again, is important if we're cutting a lot of slots, boring a lot of holes, and we need an accurate depth. A depth mic is far more precise than our dial calipers. Again, it's not a very expensive tool. It's one that's well worth adding to your list of inspection materials. While we're in the micrometer departments, let's take a look at a specialty micrometer. If we're doing a lot of boring work and we need to check wall thickness, a thickness or neck thickness or tubing micrometer is the obvious choice. We've got a football shaped spindle here that our anvil comes in contact with, allows us to measure very thin sections or cross sections of tubing, slots, material thickness, etc. Again, this has got a 10th indicator on it. It's got a very convenient soft stop ratchet system that we can get very precise measurements in the 10,000ths of an inch classification. If you're doing a lot of hole boring, they make an inside caliper, which is really a neat little tool. It's not real precise, but again, if we're holding hole diameters to 1,000ths or 2, this product will work just fine. We simply compress the legs, insert them into a desired hole, and allow them to spring out. If you're doing very precise work in hole diameters, having a good set of telescoping gauge or ball mics is something that's going to be very critical to you. Keep in mind that a V-block can serve as an excellent inspection tool. We can simply clamp a part that we need to measure or inspect in the V-block, clamp it down to the mill bed, hold it in the vise, and again take some very careful measurements either with our dial calipers or our micrometer, depending upon our application and again the preciseness of the finished part. Remember, when we're using a micrometer and we're measuring in 10,000ths of an inch, it's necessary that we use our soft stop ratchet system located on the end of the mic. 2 or 3 clicks, you can hear those audible clicks, and this allows us a very precise reading from the micrometer. If we're doing a lot of inspection work in flat stock or round parts that we need to have a uniform thickness with, another handy inspection tool, if you're doing a lot of parts and need to check them accurately and quickly, is a little surface stand fitted with a dial indicator. This particular dial indicator is made by the folks at Mitutoyo. It measures in 0.5 increments. So we would simply set our standard with a quality part, a finished part, a master part, whatever the case may be, zero our indicator, grab a handful of parts that we've just machined, run them across, and very rapidly we can check to 0.5 increments as to how precise the manufacturing process is that we're engaged in. It's got a real neat veneer adjustment, so we can preload and make any necessary adjustments simply by clamping and using the veneer dial to fine-tune our indicator. If you need to check concentricity, here's a simple gauge that we build in the shop that you can do as well. We've got a dial indicator mounted on an adjustable slide, moves back and forth relative to our base plate. We've got some ground contact points that again are indexable for different lengths of parts that we may want to check. We've got a dowel pin pressed in the back. We can simply install a part for inspection, adjust our dial indicator to the desired part that we want to check concentricity with our index finger roll the cartridge case, and we can see we've got about a thousandths variation on the dial there as we rotate the case. So this is a good example of a tool that you can build. You don't necessarily have to buy all of your inspection equipment. Again, with a little bit of creativity and ingenuity on your part, you're more than capable of designing and building your own test fixtures to aid and assist you in the type of parts that you desire to manufacture. Let's stroll over to the surface plate, and I'll show you some tips and tricks about proper layout as well as inspection of different parts using a height gauge on the surface plate.